Now, boys and girls, I hope you're all nice and comfy for another fireside chat. The topic is a new Cambrian era, Biotech 2.0. And guess what? Our speaker said they're going to be going totally overboard. So make some noise for Jennifer Hicks of Forbes. And by the way, she loves beagles, so be extra loud for her. Make some noise now, pioneers. Be loud. That's not loud. Be loud.
Hi, everybody. We did something like this last year. Oh, they have chairs. We just came from a sofa to chairs. And we decided, if you were here last year, we decided we were going to ignore you and have a conversation like we were in people's living rooms. So we have a really heady kind of topic to get through today with biohacking and biotech. And so I thought we would set the stage before I talk about these two gentlemen that are actually in the thick of it. And I want to talk about 3D printed viruses, biobatteries, biotech in space, Google's Calico project, which wants to cure aging, GMO changes in terms of making crops grow better in harsh environments like saline water. I say all those things because people may not actually think that's biotech and biohacking. And then this morning, when I introduced you to Mike Butcher, he said, "Can you make me thin and beautiful with biotech?"
I'm not sure science is up for that.
So I wanted to set the stage because these two gentlemen are actually doing things that are going to move this biotech, biohacker movement forward. We have Bill Liao, and the last time I was with Bill, we were surrounded by 10, 11, and 12-year-olds. So he founded Coderdojo, and now he's doing biocoding?
Biocoderdojo.
Biocoderdojo, with kids doing biocoding. And I have Ryan Bethencourt here, is actually running one of the first Biotech Accelerator incubators in the Valley. So these guys we're gonna just talk a little bit about what is biohacking and biotech, and is it big pharma? What is it?
So I use the term biohacking.
Yeah.
And biohacking is really, in Silicon Valley, hacking is taken on a different term. It's making new things out of old, and often making them for lower cost, cheaper, better, faster. And so we really repurposed the term hacking, and we call it biohacking. So we make all sorts of different consumer technologies, different therapeutics, pretty much anything.
Some people don't like that term, though.
They don't.
Bill's one of them.
Bill is one of them.
I hate that term. I mean, you know, hacking just it has a negative connotation around the world. I'm actually a big fan of the maker movement, and I think biomaking is the way to go. And what we're talking about here is the mass democratization of biotechnology. Because, like, one of the reasons that we fear biotech is that it's been so secretive, right? It is the purview of some huge corporates that tell you nothing, right? You Google it, you get nothing, right? Because they're afraid. And what we're doing is we're saying, look, this is open source. This is available now. This is not a $1 billion problem to solve. It's a $30,000.
I think when you say biotech, I think if I asked my mother what biotech was, she'd say, "Oh my God, it's Pfizer. It's a huge drug company." No.
So then we're moving past. So the biotech of the past was really biomedical, right? So we were thinking $1 billion, 10, 12, 15 years, and a drug. And now we're moving into the realm of biotech is everything. So it's from our shirts to our detergents to crops that we grow, enzymes that we make, new biomaterials. So it's really, that's what's leading us to the new kind of generation of Biotech 2.0. And particularly, and it's something that Bill and I have both done, we can now build biotech startups for less than the cost of an app startup.
Okay, we're going to jump right into that. We're going right into the money, right? So startups today are usually bootstrapped for cash, but startups in the biotech space are bootstrapped for a wet lab. Right?
Yeah, absolutely.
So this is a big difference between what we're seeing here in the tech startup versus what a bio startup actually needs. So what's that cost?
So I'll give you an example. Maybe 5 years ago, it would have cost you about $4 million to build a biotech lab. Now we're probably talking tens of thousands of dollars. And what we're seeing is a progression from big industrial corporate labs and academic labs moving down into biohacker labs or biomaker labs.
Okay.
And then now we're moving into individual labs. So people have a little lab set up at their home.
Okay.
And the automation is cheap.
Okay.
Right? You know, because previously you would go, okay, we're going to set up a biolab, we're going to spend millions of dollars, and we're going to find investors who are going to take a $20 million bet on a 20-year project that has just as much chance of failing as that app over there that costs $5,000.
Yeah.
Right? And instead, we're saying, look, the automation has got so cheap, the lab costs have got so cheap, the data and the coding so cheap, you could set up a cheap lab, and for like 30 grand, you can do a startup. In 3 months, you're going to get a product.
But I can't see a traditional tech investor saying, hey, when you get to a biotech startup, hey, when you get some traction, come back and see me. Yeah. That's going to be really far down the road, right? So how's this space going to be funded? Seed, I think, maybe some crowdsourced
but that's just
funding.
What changed.
But don't you think people are afraid, too, that big pharma could get in it as well? Start backing some of these small companies, then you've got that big pharma thing over it.
But big companies don't typically innovate. They just acquire and hide.
That's true. That's true.
What we just did in Cork, over this summer, we had 6 teams come to our wet lab in Cork. We gave them 30 grand each, and they all produced products and stuff that you can use. And I mean,
like what? Stuff like what?
So there's a company that has made spider silk without a spider. They made it from bacteria. And spider silk is as strong as Kevlar, and they can make this stuff. Now, previously, efforts have spent $3, $5, $10 million trying to do this, have failed. This bunch of kids with 30 grand succeeded. We got a company that is making cannabinoids, the medicinal part of marijuana, right? They managed to do that in 3 months, end to end, 30 grand.
With 30 grand.
Yeah, with 30 grand. Yeah. I mean, this is where you can go to a tech investor and go, you know what? I will come back and I'll show you traction in a year.
Yeah. So
I'll show you traction in 2 years.
You could come back and show you more traction.
Yeah.
So I think, for me, and maybe this room, you just want to know, what does it look like and when can I have it? Yeah. So the spider web, making silk, how does that apply to us? So, why do we care?
So you can have a Kevlar vest for 1/10 the cost of a normal Kevlar vest, and it doesn't require any nasty chemicals in its manufacture. But there's more important things than that. Like, the reason I got into this is my daughter is a diabetic. She became a type 1 diabetic when she was 12. And as a paranoid tech dad, I looked at the supply chain, right? And I said, so if everything goes bad, right, how long does my daughter live? Yeah. And I found that the supply chain for insulin in Ireland was 3 weeks. There's 3 weeks of stock, and that's it, you're done.
Only 3.
So I said, look, well, that's unacceptable.
Yeah.
And I looked around and I thought, well, I've heard that biotech is getting more automated stuff. I priced a lab at about 50 grand where I could make my daughter insulin.
How long ago was that?
That was 18 months ago.
Okay.
It's probably cheaper now.
Okay.
But that said to me, if I could do that, and I'm a programmer, and an investor, if I could do that, I'm pretty sure that we're at the point where we can have so many entrepreneurs come in and really tackle the kinds of problems that everyone cares about.
That space needs to be disrupted then, clearly.
Yeah. That's where you get Cambrian explosion.
Right.
Tens of thousands of people going, hey, look, it's an open source world now. Yeah. That's happened.
Yeah.
It's happened now.
Yeah, I mean, we have people in the lab at Berkeley Biolabs that are making things. So the only limitation you have to what you can make with biology is your imagination. That's pretty much it. I mean, we have an entrepreneur in the lab who has made algae biobatteries. So these are biodegradable batteries made without lithium. Yeah. And they degrade, and they actually hold charge. We have wastewater processing, so turning wastewater into biofuels, specialty chemicals, happening now in the lab. And then we also have an entrepreneur scientist who's making cellulose out of bacteria. So a high-quality paper and fabrics.
And I think this is the gist of it, right? It's like, these are really practical things that are going to move our lives forward in a healthy and a quantified way. I mean, not to be tall or change your hair color. It's real things that are going to affect our lives. And you have said this, the past is not going to be the future.
The past will not be the future. Right, so when people in the valley, right, and so I live in
He lives in the valley. Who
I
would
live
guess,
in Silicon Valley, the broader Silicon Valley.
Right.
I actually live in Oakland, so I like being kind of in the valley and outside of it. I think the valley is kind of boring sometimes, so that's why I like Oakland. But when you talk to people in the valley, a lot of them have this fixed mindset of, oh, I'm going to cut a $500,000 check for the next app company or the next startup, and they think that they're going to get the same exits that they've had in the past. Right? And so they're really not seeing what's coming forward. The cost of doing biology has dropped dramatically. Sequencing has exceeded, the fall has exceeded Moore's law. Yeah. Right? So what does that mean? Right? In tech, we saw Moore's law disrupt everything. In biotech, we're exceeding that curve.
It's already there.
It's there, and it's going to keep going. Right? So what does that mean? right? It means we're going to see massive disruptive change in how people use biology.
Like, can you give us an example of that massive disruptive change? I mean, okay, you have IndieBio, right? You guys have now teamed up. You have a startup where you're giving people $35,000, not just.
We did an acqui-hire.
Yes.
You did.
So yes. So Bill, Arvind, Sean, and the team at IndieBio acqui-hired Berkeley Biolabs.
Made him an offer he refused.
This is really interesting because you think of all the community that started spreading up around here in the accelerator incubator community around biohacking. They're on the West Coast. They have a few in New York, GenSpace in New York, and then you've got BioHive and BioCurious.
We have BioCurious, Counterculture Labs.
Here's the cool thing, and we have Cork. Right? We have a strong biotech and a biohacking sort of triangle now happening with New York, San Francisco, and Cork.
And it's spreading. The interesting thing is it's spreading. So actually here in Vienna, there's a biohacker space. Actually, the team from Briefcase Bio
was one of our teams.
One of your teams? Okay.
Came from Austria as well. Yeah. So it's spreading globally, the whole biohacker movement.
We talked about this earlier, talking about how a lot of startups come out being not global from the start, but you're telling me that a lot of the biotech is, in fact, global from the start because it cures something.
Well, they've grown up in the internet age, right? So they're collaborating globally anyway. And our Cork program in particular is targeted at scientists and undergrads who have looked at the university course and gone, you know what, I could spend the next 5 years doing this and maybe get a job at Pfizer. Yeah. Which is nothing wrong with that, but...
Oh, well, maybe.
Or I could actually take a punt on this and I could spend my summer trying to build the thing that I'm passionate about. Okay. Just like any tech entrepreneur, with the same return timelines, with the same risks. And this is the change, right? This is where you de-risk something and you democratize it. Yeah. Suddenly you have this huge area of new investment, which nobody has looked at. And biotech has had a lot of broken promises, right? A lot of broken promises. And you hear a lot of really crazy stuff. You know, we're going to cure this thing, we're going to do this tomorrow, we're going to do that. A lot of that's really still very, very, very hard. Yeah. But there's a whole lot of stuff that's easier. There's low-hanging fruit. And that's where we see the initial steps are going to come from.
And the low-hanging fruit.
In the low-hanging fruit. Turning cheap molecules into expensive molecules with tiny little nano machines. You know, when people talk to me about nanotechnology, they go like, oh yeah, we're going to use electron microscopes and we're going to build these tiny little robots. I'm like, oh, how quaint. You know, I've already seen that happen. I've got all these little bacteria. Right. And if I want to make a copy of one of those bacteria, like, you know, if you make something in silicon and you want to make one copy, you need $10 billion worth of silicon fab. Right. If I make something in bacteria and I want to make 10 billion copies, I need $1 worth of sugar.
So what?
$1 worth of sugar.
What's the barrier? I mean, are we have trust issues? Are we afraid of genetics? Is this something that people are afraid of, and the masses? I mean, how come?
So a lot of people say, are we playing God? Right?
Yes.
And I think my favorite saying is, we are as gods, so we might as well get good at it. Right?
I just say we're not playing.
We're not playing. We're not playing. We're not playing. So I guess that takes us back to who's going to fund this? Is there a risk of big pharma wanting to dip into some of these innovative minds? I mean, is that a risk for people? Because the same thing with GMOs. I think the opposite risk is true.
I think the opposite risk is true. I have gone to a lot of big pharma companies, and you go to their testing labs and stuff, and you see people with like strings of letters after their name like this, and they are working on validating a single molecule, and they've been doing it for 5 years, and their tests are done by they're writing stuff out and typing it up and publishing papers and writing patents on this single molecule that they've been doing for 5 years. And actually they're very smart guys and gals, and they're like,
it's not really moving forward or anything.
With all that skill, wouldn't you just like to take that skill and actually do something? Yeah. You're like, wouldn't you like to actually be a startup entrepreneur? And a big part of what we do in our accelerator programs at SOS is provide the conditions where someone who is operated under a different covenant, whether that's academia or whether that's big pharma or whatever, we can provide conditions where they can start thinking like an entrepreneur. Because that bit doesn't change.
Right.
So there's a mindset you have to catch.
The mindset you have to get into.
And it's open, right? So the important thing is you don't need a PhD. You don't even need an undergraduate degree in biology or bioengineering. You can just come in and build.
That's a misconception, though. Yeah. You think, oh, I'm not a scientist. I don't have a biology degree. I can't go and do this.
Yeah. And it's not true anymore.
Yeah.
So I've seen it in the... So in the Bay Area, we probably have several thousand biohackers, the San Francisco Bay Area. And I have seen multiple examples, dozens of people who've come in with no background and have basically built products or their ideas in the lab.
How is that possible?
Well, I'm not a biologist, right?
But you're sort of a genius, Bill.
I'm a coder, right? I can program, right? That's where I started, was in the tech world. And as an entrepreneur, I looked at a very simple supply chain problem. How do I make human analog insulin? And it's actually really hard, but it's also really well documented. So it is possible that you can read up on this stuff and you can get a few hints from friends and you can say, actually, this is doable.
It's the DIY scientist label that gets put on things as well, right?
But this is where community is so important.
But I mean, ultimately, we are biotech, right? I mean, if you look at ourselves, like, what is a human, right? A human is a mixture of a microbiome, human cells.
Actually, every human is two humans doing a genetic experiment.
Right? The genetic experiment.
It's like 10 times the number of bacteria cells reside on us than human cells. We have a range of viruses. Our DNA is composed of about 11% viral, right? So we are GMOs. We are genetically modified organisms.
Yeah, that's a really good way to put that into perspective. I find that some people get very upset when you start talking about GMO. Same people that get upset about GMO are the same people that use science to validate global warming. Okay, that's neither here nor there, but science definitely has a place and a role in everything.
Fear causes denial. We know that.
That's true.
Right? The first thing, when you're afraid, you deny.
Yeah.
Okay, so that's the first thing. But you actually have to look at what the practical implications of some of these things are. So if you wanted to look at where is the greatest biohazard being manufactured right now, it is being manufactured in the mixed pig and poultry farms in China. Right, where humans, pigs, and chickens get together in close proximity, and viruses go, party! Right? Excellent!
Right. Yeah, and the bacterial aspect.
It's a breeding center.
They're taking antibiotics as well, so that the antibiotic-resistant bacteria.
Yeah,
it's a breeding ground.
That's where the big experiments are happening. Now, you don't have to change the genome of something to have a huge impact.
Exactly.
Like, for instance, not many people know this, but trees actually have little bacteria on their leaves that make clouds. They blow off into the air and they coalesce clouds. So if you can plant enough trees around the equator, you can actually increase cloud cover. If you increase cloud cover by 2%, you actually end global warming. Right? And you don't need to modify anything to do it. You just need to plant the trees.
Plant the trees.
And actually, that's one of my commitments. I've got a tree planting charity.
The other tree project,
We've planted 7.5 million trees. We're targets 100.
That was a 13-year-old's idea, something, wasn't it?
My daughter.
Yes. Okay.
Said, "Do this, Daddy.
Yes, do this.
Fix the planet. You broke it." You know.
What do you think's going to happen? I mean, do you think that hackers and biotech are still going to continue to live on the fringe of things? I mean, do they feel like they're a part of this ecosystem? I mean, I wonder how many people out here would think of themselves as biohackers?
Ooh,
I think we've got like
how many people?
One. We got one.
That's good. Yay.
Round of applause. Two. Yeah, excellent.
And what about biotech? How many people consider themselves in biotech?
Oh, there's one.
Come talk to us later.
I think if you broaden it out
on the floor down there.
If you broaden it out and say how many people are interested in science and biology, just an interest, right?
Yeah.
Now we
have there's your point right there.
That's where it is.
70-80% of people.
Yeah.
And that's where we start.
Yeah.
And that's where we start. And that's where you can start learning how to do it. In the same way you can start learning how to play with a computer and program it.
Right.
That's why we're going to do Biocoderdojo for the kids.
Let's just take 1 second to talk about kids biocoding.
Yeah.
You and your army of kids.
So like Coderdojo has produced about 35,000 kids every week so far who can code.
Okay. Now
and we're actually starting the first Biocoderdojo because DNA is digital.
Okay.
All right, and there is stuff that you can do where you can write in a number of high-level languages that can then be translated to DNA to make interesting stuff.
Do they know what they're doing?
Yeah, of course.
Okay.
Yeah, I mean, they have specific goals. I've seen some very interesting ideas that I think will appeal to kids. For instance, one of the teams that was in our accelerator did a color-changing flower. right? That's what they're working on. Is a petunia that starts off blue in the morning and it ends up orange, red at night.
What control you have as a child to change the colors around you in nature, right? It's like a movie. It's sort of like a movie.
Yeah. Another team that I saw in La Place in France, in their biohacker space or biomaker space, is they made a pen where you feed sugar in one end and colored ink comes out the other end, because the bacteria change the colors, and depending on the pH, you get different colors coming out of the same pen.
That's amazing.
And we can use it for ethical issues too, right? So vegan cheese was a successful project that one of the biohacker spaces I'm involved with was able to raise money on Indiegogo to make vegan cheese. So they actually make out of yeast, they make casein.
Yeah. Do you take a slight, you just made me think of something, a slight step into the crowdfunding area for biotech, and I'm not a huge fan of it in order to get you going and get out the door, but is that an area of funding that this will be looking to increasingly, or?
Oh, yeah.
Okay.
Yeah.
They're gonna, well, they need that more than someone that's making an app.
I mean, you know, imagine toothpaste, right, that gives you a little bacteria in your mouth that continually freshens your breath throughout the day, and by the way, gives you a tiny little dose of vitamin C continuously, right?
I would want that.
Who wouldn't want that, right?
I would
but
want
that's
that.
doable,
Yeah.
right? You know, one of the things also, we see that people who have allergies, right? There is recent research that shows that the less the diversity is in your gut microbiome, the lower the diversity, the more likely you are to have autoimmune diseases and allergies.
Okay.
And if you can increase that biodiversity in your microbiome, wow. And I mean, we're talking way beyond your cult here, right?
Right. This brings us to Andrew Hessel, who says he can 3D print a virus that will, you know, maybe one day attack cancer cells. And you said, fairly, you said, that's great, but you know, that's probably not the area where we're going to see commercialization of these types of things in the health area. Yeah. So where is that commercialization going to come first?
It's going to come in places which aren't heavily regulated, right? Because heavy regulation always it's something to ram into, right? So one of the teams that was in you know, our accelerator program, so Moo-Free, they make milk without cows. Right?
What's the name?
Moo-Free.
Moo-Free.
Yeah. Okay. Right. So they genetically modify yeast to make milk proteins and caseins so that they can mix up actual milk.
Without milk.
Without the cow, right?
Yeah.
And like industrialized cows are actually quite miserable. It's not like replacing pasture cows. It's replacing the feedlot cows and the antibiotics and all that horrible stuff. But the stuff they make, the product, is not genetically modified.
Okay.
The thing that makes it is. But that's all filtered out.
Right.
So what you end up with is molecules that are absolutely indistinguishable from what came out of a cow at a lower cost, just the same nutritional value, identical stuff, not regulated.
And how does that make it into market? How does that make it into my glass?
Well, you know, their plan is literally to create vegan milk and have it on the shelves within a couple of years' time.
Oh,
and they've been funded to do it. You know,
I think that's probably a pretty big thing, vegan milk.
Yeah, exactly.
Next month is vegan month, so.
Yeah, exactly. So there's abilities to find many markets for things that are actually quite prosaic.
Don't need to be heavily regulated. That makes sense.
It's disrupting that idea that biotech has to be something that only PhDs and professors do in a lab, takes 10 to 20 years and costs $1 billion. Now, today, we're doing it for under the cost of developing an app for thousands of dollars, tens of thousands of dollars, and anyone can do it. All you have to do is learn how to do science. And they're cookbooks, they're called protocols, and you can teach yourself how to do them.
That's cool.
And not only that, the protocols are getting automated and shared in the cloud.
In the cloud.
So you can start to drag and drop this stuff. You can start to write snippets of code and actually have that work. And you can share it around the world. But most importantly, you know, it's about giving that opportunity to everyone, but also it's about looking at things from the perspective of what can I make that isn't genetically modified?
That's a good way to look at it.
Right, as an output. So, but what can I do? How can I make these tiny little factories, bend them to my will, but actually produce something that everyone can accept because it's identical?
Drink and enjoy,
As a biohacker, I tend to view things a little bit more radically.
Of course you do.
I want to democratize access to the tools of biology. I want everyone to be able to do genetic engineering at home And I want it to be the case that governments can't stop it.
Yeah,
right?
that's sort of been the problem, right? I mean, the people, there is some sort of fear out there around what people are going to make. I mean, I don't know if that's been tainted by Hollywood or science fiction or.
I mean, think it's powerful, right? When you think if someone's mother is dying of cancer, why can't they have access to the tools that maybe they'll cure their mother's cancer? Maybe they'll figure something out new in science. Like, why aren't we doing that? There was once a day of citizen scientists, right? I mean, these were the Darwins of our time, of the past. Yeah. Right?
Yeah, we're coming back to that time. Science is incredibly important.
I think so, and also...
And also, being able to allow the collaboration of people, that's super important. Because the more people that you enable with these tools, and make it open source as much as possible, you know, like open source systems are much more tolerant to viruses that are man-made computer viruses than closed source systems.
Yep.
I think the same when it comes to the safety issue. The more people that you get that are people of goodwill that spread this technology around, the quicker we'll respond to any threat.
Yeah, I like the Hive Bio out in I think it's Seattle, right? Yeah. It's very interesting because they just opened this lab, and it's an open tennis clinic. Like you can come in and create whatever you want. I like that. And then it made me think a lot. We talked about this briefly about, you know, seniors, or let's call them silver pioneers, if you'd like. They unknowingly, they would not call their hip or their insulin pump or their pacemaker, they would not call that biotech.
So
but they've been biohacked for a while.
Yeah. The elderly of today are transhumanists, right? Transhumanists exist today. The reason they can walk is because of their hip implants.
But they wouldn't call that biotech.
No, they wouldn't call it biotech.
It is real biotech.
It is. But they wouldn't call it if you know.
Amgen have a drug that strengthens the actual density of the bones, right? And the reason that that people with osteoporosis are able to strengthen their bones is because they get injections of biotech products.
There's a company in Finland that's working on that right now.
Without advances in biology, anyone over the age of about 50 would be dead right now.
Yeah. Right. Yeah. But this is again this labeling type thing because I think they don't understand it. If we said that to them, or you went to your grandmother and said, "Oh, Grandma, you've been biohacked," she wouldn't understand. So this next generation of people that will live with biohacking, what does that look like? Is that the tattoo that
they don't have to understand it? So I would say they don't have to understand it. It just works, right? It's just technology. It's like your grandmother's eyesight is failing. She gets a procedure done onto her eyes, right? Her hips or her bones are frail. We strengthen them. The next generation of biohacker, and they're actually called grinders. So many of you may not be familiar with this term, but grinders define themselves by their willingness to do essentially medical procedures on themselves.
Oh yeah, I think those kind of fringy things take us in a...
Fringe now.
Yeah, fringe now. Okay, fair enough. Fringe now.
But these
mind
things
you, I disagree. I think people need to understand it, and I want the understanding to spread. Because it's actually understandable now. Yeah. Right? That's the thing that we have to learn, is that this stuff can be grasped by people with basic engineering skill.
Yeah. He's coming to get us. Yeah. He's going to pull us off the stage with a hook.
Yep. And applications, by the way, applications are open for IndieBio for the San Francisco batch, and they'll be opening for Cork as well.
Then you can
so if you know someone,
you can catch these guys off stage. They'll be happy to talk to you about it.
Great.
I swear we're done.
No worries at all.
Okay.
Thank you so much for this mega speech.
Thanks. We done?
Thank you, Jennifer. Thank you, Bill. Thank you, Ryan. Thank you so much.